Hey, how's it going? Master Cal here, a math expert for the AA Discord server, and today I'm going to be giving an introduction/review tutorial on how to solve systems of equations. Systems of equations is a concept that you first learn in Algebra 1, and it is a very important concept because it's one that you will definitely be using in higher math and also in sciences. I know for me, I use this concept a lot in college physics when there's different values and different equations and I don't have all the information given to me. So a system of equations is basically a group of equations that have the same or similar unknowns. And when a system of equations is only solvable when you have n equations and n unknowns. Means you must have the same number of equations, the same number of variables and equations. If you can solve it with 2 equations and 2 unknowns, with 3 equations and 3 unknowns. But if you have 2 equations with 3 unknowns, then you can't fully solve it. The best you can get is 1 variable expressed in terms of the other 2. And in Algebra 1, we're focused basically on just 2 equations and 2 unknowns. So there's several different ways to solve a system of equations, and the first method is what is called elimination. And elimination is, as the name implies, you eliminate one variable, so that you have one equation that and one variable that you can solve for that variable, then you can plug the result of that variable in and you can solve for the value of the other variable. So I'll give you an example. Say I have a system 3x plus 2y is equal to negative 8, negative 6. Sorry about that. Negative 6. And 5x minus 2y equals positive 8. So notice here that I have a plus 2y and a minus 2y. This makes this system a very good choice for elimination because I can easily get rid of the y value. If I just add these 2 equations together, I get 8x is equal to 2. Then I divide both sides by 8 and I get x is equal to 2/8, which is just the same as 1/4. Now, if I plug this back into, let's say, this first equation here, I get 3 times 1/4 is plus 2y is equal to negative 6. So 3 times 1/4 is 3/4. I can subtract from both sides. Negative 6 is the same as negative 24 over 4, so this becomes 2y is equal to negative 27 over 4. And then if I divide by 2, I get y is equal to negative 27 over 8. This means that the answer is 1/4 and negative 27/8. And I just made up this system on the fly, so I got fractions in my answer. It is possible to get fractions, but probably a lot of the problems you'll have to solve will have simple whole numbers or integers. And so let's take a look at this. So over here, I have a graph of these 2 equations. The first one being the red line, and the second one being this blue line here. And now notice that they intersect at this point right here, which is 0.25, negative 3.375. And if we look at what we got, the answer to this system was 1/4, which is 0.25, and negative 27 over 8, well, 8 goes into 27, negative 3 times, with 3 left over, because 8 times 3 is 24. And 3/8 is 0.375. So that is exactly what we get. So the answer to a system of equations is where those 2 lines intersect. So if the equations are easy to graph, you can also solve a system of equations simply by graphing and looking at where they intersect. But this is the algebraic way to solve it, and this is the graphical way to solve it, and both should give you the same answer. Sometimes when to use elimination, it's not as straightforward. So if I have this system here, 4x plus 3y is equal to 10, and 2x plus 5y is equal to 32. On first glance, it doesn't sound like I can use elimination. But notice that 4x and 2x, well, 4 is a multiple of 2. So I can multiply this entire equation by -2. So -2, and I also have to multiply this side by -2 in order to make it balance. So I get now my system is 4x plus 3y equals 10, and now I have -4x minus 10y is equal to, that would be -64. So 4x minus 4x is 0, 3y minus 10y is -7y, and 10 minus 64 is -54. So I get y is equal to positive 54 over 7. Then I can substitute back into it. Doesn't look like I can easily get rid of the fraction, so I'll just do the first one. So I have 4x plus 3 times 54 over 7 is equal to 10. 3 times 54 is, let me just pull it up on my calculator really quick what that is. 162. So I have 4x plus 162 divided by 7 is equal to 10. 10 is 70 over 7, so if I subtract, I get 4x is equal to, that would be -92 over 7. Let me double check that. Yes. And then if I divide by 4, 94 does divide by 4, and I get x is equal to -23 over 7. So the answer to this system is -23 over 7, which is a little bit less, I should say, than -3, and then 54 over 7, which is a little bit less than 8. So that's the first way to solve a system. The second way to solve a system is through the use of substitution. Substitution is when you get one variable, one variable in terms of the other variable, so isolating one variable, and you substitute that into the other equation. So here I have x plus 4y is equal to -5, and 3x minus 6y is equal to -7. This x here doesn't have any coefficient, which makes it an easy candidate for substitution because I can easily get x in terms of y without any messy fractions. So I can say that x is equal to minus 4y minus 5. I can now substitute this into this other equation here. So now I have 3 times the quantity -4y minus 5 minus 6y is equal to -7. And now I have one equation, but only y is a number, so I can find what y is. So expanding this out, I get -12y minus 15 minus 6y is equal to -7. Combining like terms, I get -18y, and then I can add 15 over, and I get is equal to +8. So I divide, and I get y is equal to -8 over 18, which is the same as -4/9. Now that I have that, I can substitute that into x. So I get, or well, not into x, into y. So now I have, I'll do it into this second equation here, 3x minus 6 times negative 4 over 9 is equal to negative 7. And I chose the second one just because the 6 and the 9 have a common factor of 3, so that could make the fraction a bit simpler. You could substitute into this equation too, and you should get the same answer. It does not matter. It's just personal preference for my sake. So I now have 3x minus minus is going to cancel. And so 6 is 3 times 2, so that becomes 8 thirds, because that would be 24 over 9, which has a common factor of 3 that reduces to 8 thirds, so yeah, that is correct. And that's equal to negative 7. Subtracting 8 thirds, negative 7 would be negative 21 thirds, so I get 3x is equal to negative 29 over 3. And then I divide, and I get x is equal to negative 29 ninths. So the answer is negative 29 over 9 and negative 4 ninths for this system of equations. And that's how to use substitution. If you see that there is a variable here that does not have any coefficient in front of it, or maybe you get lucky and maybe there's no x here, it's just a y is equal to something, for example, then substitution would be your way to go.